welcome to the session. It's great to see so much interest in discovering engineering at ANU. I'm Kylie Catchpole. I'm Deputy Director of the School of Engineering. So what is engineering? Well, engineers create things that have never been created before, and people don't often appreciate just how much engineers do and the wide variety of things that engineers do. So I thought I'd go through a few examples. Here's one, the Mars rovers. So this was an enormous engineering effort. Curiosity was the first one to get onto Mars, and it took a huge amount of precision to actually get that precisely to Mars. They had to take into account things like changing the magnetic field due to the rotation of the Earth. They had to get that landing so carefully and to not actually damage the rover, and it worked and it exceeded all expectations. And now, we've had a series of rovers, including Perseverance at the moment, which I've heard just recently is actually creating oxygen on Mars, about as much oxygen as a small tree. So that's quite amazing what's been done. Here's another example, renewable energy. So in order to address climate change, we have to completely change the way we're using energy over the next 30 years. Energy is responsible for around 70% of greenhouse gas emissions. So if we want to get to net zero by 2050, then we have to completely change the energy system. This is the largest change in the energy system since the Industrial Revolution. This has to happen by 2050, so that's within your careers, right? So it needs to be achieved by the time that young people are retiring. So it's an enormous challenge, but also an enormous opportunity. Another example, robotic exoskeletons for paraplegics. Engineering is always for people, and we've seen in those first two examples, getting rovers onto Mars is about inspiring. It's about what's possible for humanity. Renewable energy is because people want a sustainable future. And in this example, we're enabling people to walk who were not capable of doing that before. Here's another example, again, a very different example in smokeless stoves for developing countries. In a lot of developing countries, they're actually cooking with fires inside, and it causes tremendous health problems, especially for children. So this is an engineering solution to develop smokeless stoves so that they can avoid all those health problems. And of course, obviously they have to be extremely cheap for people to be able to afford them. Engineering is often about things going wrong, and it's about fixing things going wrong. A lot of the time you try and make something and it doesn't work the way you expected. Here's a particularly spectacular example. You've probably heard of the James Webb telescope, which is bringing back amazing images now of distant galaxies. But before the James Webb telescope, there was the Hubble Space Telescope. And when it was first put into orbit, they'd actually ground the lens to the wrong design. So very embarrassing mistake. It was ground perfectly, but they'd used the wrong design. And so when they put it up, you got images like in the top right there, very blurry. And what they were able to do is actually fix it while it still remained in orbit with a very clever solution using a camera. And so in the end, they were able to create those beautiful images that you see on the bottom right there. Engineering requires integrity, and this is a good example of what happens if you don't have integrity. This is the VW scandal a number of years ago. What they actually did was the pollution sensors in the cars were giving incorrect readings. They were showing that they weren't emitting polluting gases when they actually were, and so they were passing emissions tests when they shouldn't have been. And this created an enormous amount of extra pollution. It cost several of the top people in their company their jobs. It cost billions of dollars for the company. So, and of course, it created extra pollution, which is the exact opposite of what they should have been trying to achieve. So engineering always requires integrity. Engineering needs diversity, so we need a range of different viewpoints. All kinds of backgrounds and identities contribute to better engineering. This is an example of how it can play out. Pilots from one background, when they're flying, they're trying to fly in as safe as way as possible, for example, avoiding any clouds, and they're giving feedback on ways you can do that better. Pilots from another background are looking at what happens if you get into challenging situations, what happens if you fly through a cloud, what happens if the airplane begins to stall. And so they're learning how to respond to those situations. So both of those backgrounds are providing important feedback to be able to improve that training. And so this is an example of how we need people from all kinds of backgrounds, genders, all kinds of identities in order to achieve the best outcomes. Okay, so based on all of these examples that I've given, what kinds of skills and attributes do engineers need? Above all, you need curiosity and creativity. When I ask the engineers in our program, what's the main things that motivate them? That's what they say, curiosity and creativity. It's about learning how the world works, and it's about creating something new that hasn't existed before. It's very exciting. But a whole heap of other things as well. You can see enthusiasm, communication, imagination, logic and mathematics, empathy, troubleshooting, design skills, integrity. All of these are important for engineers. All right, so that gives you a broad overview of what engineering is like. It's much bigger than most people imagine. So there's a lot of opportunities in all different areas. And I want to go through now some of the areas that you can specialise in if you do an engineering degree at ANU. So first up, renewable energy. This is my favourite because it's my research area. I do research in solar energy and also in energy systems, working out how to make our energy system more resilient in the face of the change in the energy system and also in the face of climate change. So there's all kinds of things that you need to consider in order to make that work. You need to make all the individual technologies work as well as possible to be efficient, to be cheap, and you also have to figure out how you can integrate them in the system as a whole in order to get a low emission system and get to net zero eventually, right? By 2050, this is what we're trying to achieve. Another major that we offer is Aerospace Systems. So a big motivation for this is it's become a lot cheaper to put things into space recently, and it's opened up a range of different opportunities in communication, in monitoring, in defence. And so aerospace engineers design and integrate these systems for space applications and for aircraft. And so the opportunities there then with commercial aircraft and defence industries. We also have a major in environmental systems, so that's looking at how environmental systems work and how we can manage those systems. And just to give you an example of that, we can consider water. So in the environmental systems major, you would look at how water flows through the landscape. So that's above ground and below ground. Very topical at the moment because of all the flooding that we've had, of course. And so environmental engineers will learn how to manage those systems, what kind of infrastructure you need, how to monitor things in order to get the best outcomes for people and the environment. Another major we offer is Mechatronic Systems. So this is about integrating mechanical, electrical and computing technology. So you're looking at automation. Automation is a huge trend in all kinds of systems at the moment. Many things that have previously been done manually are being automated. And so Mechatronic Systems is looking at the robot technology, for example, driverless vehicles, for example, drones, all of these kinds of systems that you can automate and open up new possibilities. Another major is electronic and communications systems. So this is the science and technology behind all of these things that we're using all the time in our lives these days. For example, mobile phones, broadband wireless. It gives you the fundamental understanding of these sorts of systems so that you can design improved ones in the future. As Chris said there's a range of other exciting opportunities that you can take advantage of while doing a degree in engineering at ANU. So these are extracurricular activities, ANU rocketry, ANU solar car racing, Engineers Without Borders, and Engineers Without Borders focuses on humanitarian engineering, so helping disadvantaged people in developing countries and in Australia. I know the solar car racing team, there's a team of about 30 students, and in a couple of weeks they're going to do a practice and they're going to drive their solar car to Coober Pedy and back. So that sounds like quite a fun thing to do. The rocketry team has also been doing some fiberglass and building things just outside our offices at the moment, so they've been very busy as well. To give you an idea of the structure of the degree, this shows you the degree program for years 1 to 4 and broadly what you'd be focusing on in each part of the degree program. So an essential part of the degree program at ANU is to have this broad base across all areas of engineering, and that gives you the possibility to work on a wide range of areas. It allows you to investigate the areas that you're interested in before specialising in your later years. So in the first year, you focus on the engineering fundamentals. That's essential maths, physics, computing, electronics and mechanics. You also start doing the systems engineering projects. So that starts from first year as well. So you're working in teams to design and make things straight away. So you get an understanding of what it's like to actually be an engineer. Then later in your program, you have the engineering majors. So that was the majors that I just described, and that's where you get a chance to go deeper into an area of specialisation. Throughout the program, you can do a range of electives to explore other areas of interest. The Bachelor of Engineering in Software Engineering has a similar structure, except in this case, the fundamentals are computing fundamentals, so that's essential maths and computing in the first 2 years, and then a specialisation later on in software engineering. And this is the Bachelor of Engineering R&D program. So as Chris mentioned, the standard program has an ATAR of 85. This program has an ATAR of 98. And the difference here is that you get the opportunity to do these research and development projects throughout your degree program. And so that's to work directly with an academic to do original research and discover new things. So for example, I've been supervising a couple of students lately. I've supervised one student who's working on new designs for improved solar cells, and supervised another student looking at how you could improve the resilience of Australia's electricity system. All right, so I hope I've given you a bit of a taste of what engineering at ANU is about. It's a very exciting area. There's lots of different opportunities in all kinds of areas, and to get a really solid grounding in the fundamental maths, physics, computing, design skills that you need, and then to specialise later on in an area that's particularly interesting to you. So with that, I'll finish and very happy to open it up to questions.
I was going to ask, is it common for students to get internships while they're studying in the 4-year course?
Yeah, a lot of students do internships. There is a requirement to do some work experience in the program, and so that students arrange that themselves to do some work experience. So that's part of the program for everyone. But there's also opportunities to do internships as well, so a more substantial practical experience. So the question is, what's the weekly workload? Yeah. So the standard load is, this is cross ANU, the standard load is 4 courses, and the contact time will vary between courses. You may have 2 to 5 hours actually contact time, and you're usually expected to spend 10 hours per week on each course. So the expected workload is 40 hours per week. The actual contact time per course is something more like 2 to 5 hours, and then there's extra work that you do outside that time. And there is flexibility, of course, for people who need to adjust their workload at any at any point. You can just enrol in less courses for a semester if you need to adjust that. Yeah.
Is there an opportunity, say if you don't get into the R&D engineering, but you do well in the first year of the Bachelor, could you transfer to the R&D engineering?
Yes, it is possible to transfer to the R&D degree, yes, after first year, that's right. Mm-hmm. Similarly, it's also possible to transfer to engineering from, for example, a science degree after first year. So this is just another possibility.
Yeah, what I see is in a period of 4 years of study, I see the first 3 years is quite broad, like you study across, and then only in the 4th year you go for specialized studies?
No, let me see. Here we go. So the first 2 years are broad, and then in the final 2 years to do the specialised study. So this gives students a chance, well, it gives two things. It gives students a chance to understand what's involved in a particular area that they might want to focus in, and it also gives them a broad background that we find is very advantageous in their future careers. Often engineers need to talk with people from a range of backgrounds, especially, in fact, they need to talk with engineers in other backgrounds. And what we find is having this broad background and the focus on design and systems projects means that engineers from ANU are often put in leadership positions when they're put in a engineering team. They may be supervising a bunch of engineers who'd done a more specialised degree because they have the ability to look across the whole project. Yep.
Can you do like exchanges where you're doing engineering?
Yes, you can do exchanges. In that case, it's your responsibility to do courses that are equivalent to the courses done at ANU. One way to do that is to make use of your electives. So people going on exchange often make use of their elective courses because the courses won't be directly comparable, but sometimes you can find courses at an overseas university that are directly comparable, and then you can make an application for it to be considered as equivalent to a course done at ANU. Yep.
I'm hopefully going to Switzerland next year in a year to EDH, which I think is about 4th or 5th in the world for engineering. And I'm doing a double degree, so I don't have electives, but I was able to find and talk to course conveners that would allow me to do my mandatory units over there because they were closely related. Global Programs is a fantastic program, and there's a whole bunch of universities that you can go to all around the globe pretty much. Engineering, it is a bit more difficult from the discussions I've had, but you can certainly make it work, especially if you've shown a strong academic background. You can definitely make it work.
Do many students combine 2 degrees?
Yeah, it's very common for students to combine 2 degrees. So yeah, that's a way of doing, if you're not quite sure, if you want both qualifications or you're not quite sure which you're most interested in, that is a common thing to do. There's lots of possibilities. What's one of the key ideas at ANU is that you can combine pretty much anything. So there's lots of possibilities there. I mean, people also sort of decide at different points, right? So it's important to realise that what you enrol in isn't necessarily what you finish. So sometimes people will enrol in a double degree and then go, oh, this is the only one that I'm really interested in, and then I'll finish a single degree. This is fine. Similarly, you could start a single degree and change to a double. So I guess my key message is don't feel that you have to decide your entire life at the end of year 12, that there's lots of possibilities to adjust your direction as you go along.
Yeah, and I'll just chuck a quick side note on that as well. There's no harm in changing your degree. I'm 2nd year now, and I've seen so many of my friends change degrees, jump into engineering, out of engineering and other disciplines with double degrees and single degrees. Because a lot of it is broad initially, you do get a good year or 2 years to be able to decide, really. And a lot of people do pick up extra degrees, as was mentioned, because you find out once you've done study or research in this particular area, you find out what you're passionate about, and that may lead on to something else. By all means, year 12 is like the beginning of the decisions. It's not the biggest, most influential decision that you're going to have to make by like any stretch of the means.
How many electives do you choose?
How many electives? So there's, it's 8 electives in the standard program, so that's 48 units, so yeah, eight 6-unit courses. There's less, I guess, if you're doing a double degree.
If you're doing a double, then you don't get many at all.
Yeah.
But in saying that, they are very broad what you do. So
Yeah, so that's important to consider when you're deciding, shall I do a double degree or a single degree? Some people have a clear idea of what they want to focus on. Other people want to be able to explore a little more, and the electives do allow you to do that.
Can you talk about the job placement at AU?
Yeah, so as I mentioned, there's a work experience program. So that's all students undertake the work experience program, and then they need to find a placement, and that's counted for their work experience. There's opportunities to do internships. So some students do internships. We have also involvement from industry coming in guest lectures, for example, so students also get exposed to industry lectures that way. And then generally we find the ANU students are very employable and, you know, easily find jobs after their program.
HR requirements?
Yeah, so the ATAR requirement for the standard degree program is 85. That's also for software engineering, it's 85. And then for the R&D program, it's 98. Okay, well, thank you for all your interest. I'll be here if you want to ask any other questions. Yep.
thank you.
Okay.